In today's lessons, we learn how to set up matrices, how to add, subtract, and multiply the scalar. So first, what is the matrix? The matrix is a rectangular arrangement where you're going to have the numbers in each of the row and column. For example, you can see that the matrix 2 by 3. So this is what we call the matrix 2 by 3. So the way we name the matrix is by using the row and then columns. So do not forget, it's very important that we stick with the definitions, the dimensions. So this is we call the dimensions. So if you mixed up between the row and columns, you cannot find the correct elements, you cannot find the correct data, and you cannot even multiply or add. Okay, so again, row, column. That's how we find the dimensions or the size of the matrix. So for this matrix 2 by 3, you can see there's two rows. So there's one row here, and this is the first row, this is the second row, this is the first column, second column, and this is the third columns. Okay, so now moving on to how to find the elements. Each of these numbers right there, we call the element. Okay, or we call the entry. Same thing. So we start with, let's say this is the matrix. We call this is the matrix A, for example. And if they want, hey, give me the element A11. So this is going to be my -2 right here. A12, this is going to be a 5, and this is going to be a 6. So you have an idea how to get an element from the matrix. So what is the matrix 3 by 2 look like? Trying to do that. So let's start with this example. Here we have the matrix. What's the dimensions of this? We call 2 by 2. Okay, so we write 2 by 2. What about A21? So remember now, this is row and this is the column. So same thing with this here. So this is the matrix A, which is this one. And the 2 is, again, I'm going to start with the R, the row, and the number 1 with the column. So row and column. So row 2, column 1. So this is my first row. This is my second row. Okay, so this is the first column, and this is the second column. So I want the second row. So this is second row, first column. So second row, first column, number is 3. Alright, so let's try to do that. So let's move on to this one over here, to the matrix B. So dimensions, so how many rows? 1, 2, 3, 4. So this is the first row, this is the second, third, 4. And what about the column? 1, 2, 3, 4, 5. So we name the row first, so 4 by 5. B32, here we go, B32. So that's mean third row and fourth column. So third rows right here. So this is first, second, third, fourth, fifth. So third row, 4 columns. So third row, so you go all the way to 4 columns. It's right here. It's 3. What about B4, 3? So it's going to be 4th row, 3rd column. So 4th row, which is here, 3rd column's right here. So that's how we understand the size, the dimensions, and how to find a particular element or entry from the matrix. Let's moving on to how do we set up the matrix by real world applications. So the matrix instead of you can see number 1, number 2 is wordy, is a paragraph long, but that is the real world situations, and now it's going to be so much writing if we're talking about the real world applications, and how do we even try to do math from it. It's confusing, it's just wordy, it's just so many things going on. So the matrix simplify the real world situation into a lot simpler format, so we can easily to identify a data that we needed, in any situations. So for number 1, so please read along with me, that they say Elvira has catering family gathering and city events. So she catered 5 bag of chips, 4 dozens of cookies, 4 gallons of drink. Okay, so this is last year. Okay, and last year she also provided the city. Um, so she provide the catering, food and drink. For 14 bag, this much and this much. So we need to organize this information. So here we're going to start with this is let's start with the tips, backup tips. I'm just going to abbreviate a little bit here, and this is a cookie, this is drink. Okay, so now we're gonna break it down. So this would be the family, and now this is the city. So this is catering at the family, and this is for events for the city. Alright, so now let's put that the number from her informations. So this is the families right here. So families, 5 bag of chips. You put 5, and then 6 dozens of cookies. So put 6 dozens, and 4 gallon of drink. We put 4. Now for the CT is right here. C provide 16 bag of chips, 20 gallon of drink go here, and then 24 dozen of cookies. So how do we write this? So we have the matrix. So if we need to write this in the matrix, we're going to use the straight out bracket. We're going to put 5, 6, 4, 16, 24, 20, and then a square bracket like this, straight down bracket. So what's the dimensions? How many row? Again, we need to have the row and column. So this is row. I know some of you will make a mistake on this. So how many rows? 2 rows. And then you put the little x here. How many columns? 3. So that's how we set it up, the matrix. So let's go over operations. So what's operations we talk about? We're talking about there's 4 operations in matrix, at or any very much for operations in math period: additions, subtractions, multiplications, and divisions. So we're gonna start with, now matrix is It's a little bit different when it comes down to multiplication, especially. Um, we will get to it, okay? But for right now, stick with something easy that we know we learned before, okay? Which is addition and subtractions. So we already talked about this, so don't forget how to get the elements or data from each of the um, entry or elements from the table. Okay, so let's moving on to this. Okay, so let's moving on from this. All right, here we go. Now, so for multiplications, there are like two different type of multiplication in matrix. In the next video, we will learn how to do the uh, the dot products of multiplications. But for today, we're gonna stick with the scalar. Scalar means you multiply with a number. Okay, so now if you do the dot product or dot multiplications, or we can call dot multiplications. Okay, this is between a matrix multiply another matrix. So so that's gonna be in the next video. So we're gonna learn this today. So there's two different type of multiplications in matrix. So we have the matrix uh, A, B. So we have the matrix A, matrix B, matrix C, matrix D. Alright. So now we're gonna find all of this. So multiply the matrix with a scalar. Same thing as we can say multiply the matrix with a number. So examples over here, all you have to do is multiply numbers in each of the elements. So that's all you do. So 2 times 3 is 6. So this is 2 times 3. And this is 2 times 6. And this is 2 times 0. And on the bottom, you do 2 times negative 6. 2 times 1. 2 times negative 4. That's how you find the answers for that. Alright, let's moving on to add and subtract. So the scalar multiplication, it's just so easy. You can do this. I believe in yourselves. So now moving on to add and subtract the matrices. So make sure there's one thing we have to keep in mind. The matrix, what is the most important matrix? It's not about the numbers inside the rectangular shape. It's about the size. It's about the dimensions. So in add and subtract the matrix, they need to have the same dimensions. They need to have the same dimensions. Okay, so let's check this. So this is 2 by 2, and this is, again, this is the sign of the matrix, and this is 2 by 2. So that means we can add them up. So add in the matrix, we're going to add in accordingly one at a time. So we're going to do 1 plus 2. Okay, we use different colors here. And then we're going to do 0 plus negative 2. And then we're going to use blue. We're going to add 5 and 6. Make sure you keep them exact the row and columns. And then you're going to use negative 3 plus 0. Okay. So I color coded for you to see where its numbers are. So this is the answers in the bottom. Okay. So now moving on to this. So why this problem cannot be performed? You cannot add this matrix A and B. Why is this? Why it's happened? Because this has a side 2 by 3. Okay, this is the matrix A, and this is 2 by 2 matrix B. So we're trying to add those two matrices. You cannot, because the dimensions are not the same. Alright, moving on into, let's say, this example. Okay, so example A, I already do it for you. I'm going to do the B. So you can follow that example A, but I'm going to do one more. So we're going to start with B. So what is B and A? So focus on these two. Focus on those two. Alright, we need to find 3B. So that means we multiply 3 with the matrix B. So 2, -3, 0, 1. And then multiply this. So you don't have to put anything, just put the 3 in front of the matrix. Then you're going to multiply each of them. So keep the bracket. And then you're going to multiply 3 times 2, 6. 3 times -3, -9. 3 times 0, 0. 3 times 1 is 3. So now you're going to minus this from the matrix A. So the matrix A is -8, 0, 2, 4. So what is the size? So we need to check the size of this. So this is 2 by 2. Okay, so this is matrix B, 2 by 2. And matrix A size is 2 by 2. So we good to go. So we good to subtract or add. Okay. 3A 3B minus the matrix A. So now I'm going to color code this. Okay, I'm just going to draw a little bracket like this. So now I'm going to do 6 minus -A. That's going to give minus be 14. Okay, I'm going to do different color now. Green. I'm going to do -9. Again, minus 0. Minus. So don't forget, be -9. Okay, I'm use different colors now. I have 0 minus 2, so be -2. And then 3 minus 4, -1. Done.